So this one's about the Higgs boson, where it's at, and where to look for it. So this should, and this is a hypothesis, I almost want to just say theory right off the bat. This should be true and correct. I don't see why it wouldn't be. The Higgs boson is carried by light. Light is its carrier. And the reason that we would know this, a little novice baby brain, is because when light annihilates, it gives way to mass. It creates particles with mass. So that would mean that the Higgs boson is carried by or within light. Well, it's a boson. So since those at CERN and the LHC, the Large Hadron Collider, are ramming together hadrons and particles and looking for the Higgs boson, I'm stumped. I would think it would be common sense that if you are searching for a particle, whatever it may be, this mystical, magical particle that generates mass, you would be looking in the direction of when and where mass is being converted into masslessness, and masslessness is being converted into mass. And I could tell you right now that you're going to find that in radiation and decay. That's what light is. That's really simply just what we call it: electromagnetic radiation and its spectrum. And we know it consists of more radiation than just electromagnetic, though, unless that's what they want to call all the forces, even the nuclear, strong and weak. It's all some form of electric radiation. That's okay. But it's radiation, and it travels at a frequency that's massless. We call that light. And then we have the visible spectrum, etc. And then that which is beyond, and that which and that is below, that lower frequencies and higher frequencies that we cannot see. So electrons themselves radiate light. And so we have where do you think that's coming from? There's energy inside the light that electrons are radiating. Then they're losing mass too. So they're going through stages where it's like, what's smaller than an electron? And I could take some guesses in my little novice stage. Well, we have neutrinos. These are all leptons too. And we have muons are larger. We have smaller particles, TOS. I believe some of the bosons. And mesons, but anything, and I'm not saying that's what that it becomes, but an electron, when emitting light, and they do, when you have a current too, it's like, well, you can look. If you heat up, you don't have to heat up. Now, heat and light are inseparable phenomena. But not anybody would, yes, standard model physicists would understand that. It's just, again, beginner level. Heat and light are inseparable phenomena. You heat, even temperature, every temperature, 0.7 Kelvin. What is that? Light. There's a frequency traveling through it. Microwave background radiation. It's the smallest frequency, it's light. But heat and radiation, heat and light are inseparable phenomena. If you had a current of electricity traveling through, say, a copper wire, I love this explanation. I'll get back to the Higgs. And you had it charged with, a hefty amount of electricity. And you turn the light off and the insulation is transparent, you're going to see a glowing wire. Your stovetop does the same thing. That's heat. Well, it's emitting light. Those are photons and frequencies that are being emitted from your stovetop. Whether it's iron or any other type of material, it's heating up and turning that orange red. That's light. So it's emitting a massless energy. It's radiating. And it's hot. Heat and light are inseparable phenomena. A copper wire will do the same thing. If it has enough going through it, and it's thick enough too, you get a big thick one, you'll see that. Same with power lines. What do you think's running through that? Power line goes down, you'll see you might have so much in it it's jumping around. Sparks are flying out. Well, what are those sparks? That's electricity. Well, why can I see it? It's radiating. It's light. So, what we should be looking for is those, what we should be looking at and for is those processes and what's going on in the transformation from mass to masslessness and masslessness to mass. Because you're looking for a particle that is responsible for generating mass. So, hypothetically, I would say even, I want to say theoretically. I think I could say theoretically because it depends on how much energy it requires for the smallest particle in existence that has mass that we know of. It should be everywhere and be carried by light. And if it exists, as an anti, well, see, light should be carrying because through the annihilation you get the boson. If you want to call it just the regular Higgs with no anti, I was like, well, light annihilates. Well, it's in there somewhere because it's generating mass. The annihilation of light generates mass. So it should be everywhere then. Well, all these things have mass. So some activator or Higgs potential is already in the things that have mass. Or it's just there already. But light, well, when it annihilates, the Higgs is there. It generates mass. So you'd think that the Higgs, if it's responsible for generating mass, whatever it might be, whatever it's a part of, and this just only makes sense theoretically, it must be engaged in a process that has at least enough energy under a perfect conservation to transform light in an annihilative process, or any other process so far I think all we know of is annihilation, into mass that has enough energy for the smallest particle that we know of in existence that would be created out of an annihilation of light. And I think a black hole would show us that it's relativistic particle jets, that this can be anything, even the smallest particle. So, God kept telling you he's light. And they're looking for the God particle. Like, I'm light. And they got that. Well, that's a boson. Those are categorized, gauge bosons. So it's sort of categorized, or is categorized with light. A photon, a gluon. The weak force, positive, negative, Z. These are radiation frequency force related phenomenon. But if you're looking for the Higgs, I'd say, well, as long as you have enough energy somewhere, for the smallest particle, the tiniest little mass, the smallest mass that you can find in existence, to be generated by an annihilation of light, well, then it's at least its potential exists there as an activator. And again, it's because that process, now we have annihilators in light, and I've studied this under spin angular momentum. Circular polarity. I've looked at all these things, and there are annihilators associated with light. And I guess I just keep studying it, and I say, don't tell me I have to do this, because there's so many people working on this. And they're so learned. So, yeah, that's where it would be at. The Higgs is right there going, hey, look, I generate mass when light annihilates. The thing we've seen in a lab already, not just through theory, but we've observed, is 2 gamma rays annihilate and out pops an electron and a positron. So I can tell you what's happening already. I'm like, well, C is being lost. Anything that travels at C has no mass. So if you're generating mass, whatever's going on, it's causing C to be lost. That's in the annihilation of light. So these things are occurring, and under a perfect conservation of energy, C is being transferred into a particle with mass that then slows down and is given a charge and a spin and all of its other properties. I mean, so if I have to do it, I'll do it.